Good afternoon, friends, and welcome again to another session of mathematics, which is the inverse trigonometric functions. So, we are dealing with the inverse trigonometric functions today, and here I want to tell you that I am covering up. This is the part 1. This is the part 1 of the inverse trigonometric functions, and I will be bringing more and more parts to you. So, please keep watching the inverse trigonometric functions. This is Parijat sir classes going on. So let's straight away go into the chapter. First of all, here I want to tell you that we are discussing these different types of functions today here, and you have to be very careful what type of things I am discussing. These are the different type of functions. We will study what are the different values of x. You can put x means the angles, as you can see, the values which you can put, and y is the angles which you will get. Angles, here we are dealing the inverse, so that is why please take care that we will put what values of x here and what values of y we will get, the angles we will get. So let's get started one by one. So first of all, y equal to sine inverse of x. Please note here that I can put the values of x from -1 to +1. Please take care. I can put the values of x from -1 to +1, and I will get the values of y from -π/2 to π/2. You have to note these things. You have to note the principal value of the y will be from -π/2 to π/2. Please keep a note of this. That means outside this you cannot get anything. Okay. Next is, for y equal to cos inverse x, we can put from x value, we can put from -1 to 1, and the principal value which we will get is from 0 to y. Principal value we will get is from 0 to y. Please keep a note of this. Third, y equal to tan inverse x, I can put in place of x, I can put any value from -infinity to +infinity, and the principal value which I will get is from -π/2 to +π/2. -π/2 to +π/2. You have to know these values very, very nicely, otherwise you cannot do that. Second is, if it is cosec inverse x, please note I can put the value from -infinity to -1, and again from 1 to infinity I cannot put 0. I cannot put 0. That means I cannot put this. So I will get the value from -π/2 to π/2, but I will not get y equal to 0. I will not get y equal to 0. I will get from -π/2 to +π/2, but I will not get y equal to 0. And this is the thing which I can put from -infinity to, please watch here, let me highlight these also so that it becomes easy. I can put from -1 to 1. This also I can put from -1 to 1. This I can put from any real number. This I can put from -infinity to -1, and then again from 1 to infinity I cannot get y equal to 0. Similarly, for sec inverse x, I can put the values of x from -1 infinity to -1, and again from 1 to infinity. And please note that here I will get from 0 to pi but I will not take y equal to pi by 2. I will not take y equal to pi by 2. Next is for cot inverse x. I can put any real values of x and I can get from 0 to pi. So please pause the video and watch these values which are very, very important to you. Please watch the values which are very, very important to you. Okay, so you have to note these values. What are the values which we are getting? Very important values. These are the most important what we can get. What is my limitations of getting the values of the angles for the inverse trigonometric functions? Clear? So please keep a note of this so that you can memorize it. Next, find the principal value of sine inverse minus 1 by root 2. So this is our first sum, y equal to sine inverse minus 1 by root 2. So see how we are writing it, minus sine inverse. So please watch how we are writing it, y equal to minus of sine inverse 1 by root 2. Sine inverse 1 by root 2 is pi by 4, so it's minus pi by 4, and it is very much coming between minus pi by 2 to pi by 2, very much coming between minus pi by 2 to pi by 2. Similarly, for y equal to cos inverse root 3 by 2, see its value has to come between 0 to pi by 0 to pi, and root 3 by 2 of cos inverse is pi by 6, which is within this range. Cos inverse minus half, so see cos value has to lie between 0 and pi, so half is actually pi by 3, and we cannot take minus pi by 3. We cannot take minus pi by 3 because I cannot take minus pi by 3 because it is outside the range. So I have to do pi minus pi by 3, which is 2 pi by 3, because it has to be within this range. It has to be within this range. Clear? I have to do pi minus pi by 3 because it has to be within the range. Next, friends, principal values of tan inverse minus root 3. We know that tan inverse, the principal values lie between minus pi by 2 to pi by 2. Minus pi by 2 to pi by 2, as you can see here, tan inverse lies between minus pi by 2 to pi by 2. So using this we can get that now tan inverse root 3 is actually pi by 3, and pi by 3 can come within this, so minus pi by 3 can also come between this, so I can take this value. Similarly, y is equal to tan inverse 1 and 1, and this value of y should lie between minus pi by 2 to pi by 2, so it is pi by 4. It is within the range. Cot inverse root 3, now cot inverse root 3 is actually pi by 6, and cot, for the cot, as you can see, it has to lie between 0 to pi. For the cot it has to lie between 0 to pi. So let's see this. So here we will be doing 0 to pi is pi by 6 is correct. Cot inverse minus 1 is minus pi by 4, but it has to lie between 0 to pi. It has to lie between 0 to pi, so I cannot take minus pi by 4. I have to do pi minus pi by 4, which is coming 3 pi by 4, and it is between 0 and pi. It is between 0 and pi. Clear? Find the principal value of cosec inverse 2. Now cosec inverse 2, as you know that the principal value lies between minus pi by 2 to pi by 2, but not 0. I cannot take 0. So 2. So that means cosec inverse 2 is whose value? It is pi by 6, pi by 6, so I can easily take pi by 6, it lies between this range. COSEC minus 2 by root 3, it is coming pi by 6, pi by 3, it is coming minus pi by 3, but I know that I have to minus pi by 3 is within the range of this, so I can choose this value very clearly. Next is properties, which is again very important part, very important part. These all, sine inverse of sine theta is theta, and please remember theta will lie between minus pi by 2 to pi by 2. Already we have done, okay, all these. Sine inverse and cos inverse is, it is again 0 to pi. Tan inverse of tan theta is theta, and theta should lie between minus pi by 2 to pi by 2. Cosec inverse cosec theta is theta, and that theta should lie between minus pi by 2 to pi by 2, but we cannot take 0. We cannot take 0. Again, sec inverse sec theta is theta, it lies between 0 to pi, but we cannot choose pi by 2. This is, it lies between 0 to pi. Please keep note, already you know these values, so please keep a note of this. How to use sine inverse sine theta is theta. Please keep a note of this very carefully. These are important applications, so you have to note this. Next, evaluate sine inverse sine pi by 3. So let's get started. Sine inverse sine pi by 3. So we know sine inverse sine theta is what? Theta. Sine inverse sine theta is what? Theta. Okay, so if sine inverse sine theta is theta, that means sine inverse sine pi by 3 will be pi by 3, and it is lying between minus pi by 2 to pi by 2. Cos inverse cos 2 pi by 3 should come to pi by 3. Is it lying between 0 to pi? Yes. Tan inverse tan pi by 4 will come pi by 4. It should lie between minus pi by 2 and pi by 2, which is correct. Sine inverse sine 2 pi by 3, it is coming 2 pi by 3, but is it lying between minus pi by 2 and pi by 2? Okay, so is it lying that? So let's check. 2 pi by 3 is actually how much? 2 into 180 by 3, so it is coming 120 degree. Does not lie between minus pi by 2 and pi by 2. So then I have to think something. I will make it pi minus pi by 3. I will make it pi minus pi by 3. Now which gives me sine pi by 3, which gives me sine pi by 3. Okay, so and sine pi by 3 is actually how much? Pi means 180 degree. So 180 by 3, 60 degree, and 60 degree lies between this. 60 degree lies between this. So we have to do something so that my angle lies between this. That is our main target. Okay friends, so let's clear it off some part. So that it doesn't look bad. Okay, let's now sync again the next one. Cos inverse cos 7 pi by 6 will be 7 pi by 6. It has to lie between 0 to pi. What is 7 pi by 6? 7 into 180 by 6, which is 30, 210 degrees. Does it lie between this and this? Definitely not. So I have to do pi minus, I have to do 2 pi minus 5 pi by 6. I have to do 2 pi minus 5 pi by 6. So this is what we are doing it. So this is what we are doing, 2 pi minus pi, and now 5 pi by 6 is definitely between 0 to pi into 180 by 6, 30, which is coming 150 degree, and it is definitely between 0 to 180 degree. So this is acceptable. Okay friends, Next, so let's see the next sum. Tan inverse tan pi by 3 pi by 4, and we know it should lie between minus pi by 2 to pi by 2. Theta should lie between this. Okay, so this is coming 3 pi by 4, it will come, and 3 pi by 4, 3 pi by 4, it is coming 4 4 just 16, 4 5, 135 degrees not coming between this and this, so I have to do, it is pi minus pi by 4, it is coming minus tan pi by 4. Okay, so it is coming minus pi by 4, which is coming between minus pi by 2 and pi by 2. We have to do pi minus pi by 4. So tan pi minus pi by 4 is coming minus tan pi by 4. Please keep this. Tan pi minus pi by 4 is coming minus tan pi by 4. Okay, so minus goes inside, so tan inverse and tan will cut, and this is the answer, and this lies between this, so this is the correct one. So friends, another very important application is, you have to note here, this is once again another important applications, which is what, please keep a note here, that sine inverse sine theta is not only theta, it is theta only when theta lies between this, otherwise not. So in the other cases it should become minus pi minus theta if theta lies between this, it should become pi minus theta if theta lies between this, it should become minus 2 pi plus theta if theta lies between this. Okay, so if theta lies between, so that is the case which you have to understand here, in which case the answer will be what, if the theta lies between minus pi by 2 to, if your angle lies between minus pi by 2 to pi by 2, it will be, you have to take only theta. If your angle lies between minus 3 pi by 2 to minus pi by 2, you have to take minus pi minus theta. So please keep a note of this. Second, cos inverse cos theta is not only theta, it is only theta when theta lies between 0 to pi, and if it is, it will become minus theta if the angle lies between minus 0, minus pi and 0. It will become 2 pi minus theta if the angle lies between pi and 2 pi. It will become minus 2 pi plus theta, minus 2 pi plus theta if the angle lies between 2 pi and 3 pi, 2 pi and 3 pi. It will become minus 2 pi plus theta. Similarly, tan inverse tan theta, it is theta only when it is between minus pi by 2 to pi by 2. If it is between minus 3 pi by 2 and minus pi by 2, it becomes pi plus theta. If your theta is between pi by 2 and 3 pi by 2, it becomes pi minus theta. And if your theta is between 3 pi by 2 and 5 pi by 2, it becomes pi theta minus 2 pi. Please note this, which is very, very important, very, very important. So please keep it in mind. These are the most important angles which you have to take care of. Next is express in simplest form. Number 1, tan inverse root over 1 minus cos x by 1 plus cos x. Your x lies between minus pi and pi. Your x lies between minus pi and pi. So let us now start. 1 minus cos, please note here, 1 minus cos 2x is 2 sine square x, and 1 plus cos 2x is 2 cos square x. So keeping this in mind, 1 minus cos x will be what? 2 sine square x by 2. 1 minus cos x will be 2 sine square x by 2. 1 plus cos x will be 2 cos square x by 2. 2 and 2 cuts. Sine square x by 2 by cos square x by 2 is tan square x by 2. So it becomes tan x by 2. So it is x by 2. So the simplification is x by 2. Similarly, please keep a note of this also. Cos 2x is cos square x minus sine square x. Please keep a note of these formulas which you will require. Okay, so here cos x I can write it as cos square x by 2 minus sine square x by 2, and 1 plus sine x. Please note here 1 plus sine x. 1 I've given here 1 plus sine x. We know that 1 can be written as sine square x by 2 plus cos square x by 2, because sine square theta plus cos square theta is 1. So here we put, and sine 2x can be written as 2 sine x cos x. So sine x will be 2 sine x by 2 cos x by 2. So here we have written, in place of sine x I have written 2 sine x by 2 cos x by 2. In place of 1 I have written sine square x by 2 plus cos square x by 2. Now upper one is a square minus b square formula. So here is a plus b into a minus b, and lower one is the formula of a plus b whole square. So cutting this, we are getting this. Now dividing by cos x by 2 up and down, dividing by cos x by 2 up and down, each term I am dividing by cos x by 2. So this becomes 1, this becomes tan x by 2, this becomes 1, this becomes tan x by 2. Now tan 1 is actually tan pi by 4. Tan 45 is 1. So in place of 1 I am putting tan pi by 4. Okay, so tan pi by 4 minus tan x by 2 by 1 plus this I am writing 1 into, so that 1 is tan pi by 4 plus tan x by 2. So after this it becomes simplification. So it is tan pi by 4 minus x by 2, because tan a minus b is tan a minus tan b by 1 plus tan a tan b. Okay, similarly tan a plus b, let me write it here only. So if I just simply add it, 1 sine, that's it, I will get both the formulas. So now let's see. So that means here we find out that we are getting tan a minus b. Now tan inverse and tan will cut, so it is pi by 4 minus x by 2. Clear? So now let us see this. Tan inverse cos x by 1 minus, now cos x is already last sum, so it is using this formula, cos 2x equal to cos square x minus sine square x. So cos x will be cos square x by 2 minus sine square x by 2. So using this and then in place of 1 I am writing cos square x by 2 plus sin square x by 2. In place of sin x I am writing 2 sin x by 2 cos x by 2. So upper one is a plus b into a minus b, and lower one is the a minus b formula. So square and this cuts, so it is this. Now again dividing by cos x by 2, each term dividing each term by cos x by 2. So we are getting 1 plus tan x by 2 by 1 minus tan x by 2. This 1 can be written as tan pi by 4, and this is 1 into, so that is why that 1 is written as tan pi by 4. So it is looking like tan a plus tan b by 1 minus tan a tan b. So it is the formula of tan a plus b, okay, and it is pi by 4 plus x by 2. Okay, so next is again very important things. Please take a note of this. Very important things are there. If a square plus x square is given, take x equal to a tan theta or x equal to a cot theta. Please note it. If a square minus x square is given, take x equal to a sin theta or x equal to a cos theta. If x square minus a square is given, take x equal to a sec theta or x equal to a cosec theta, any one of them. And if this is given, this format is given, take x equal to a cos 2 theta, and if this format is given, take x equal to a cos 2 theta. So these are the same things. Please note these very carefully, because these are the applications. If you know these, you will be able to do the sums very fast. So that is one advantage of knowing these type of tricks. Next, let us see the applications. First one is tan inverse x by root over this. Okay, so using this we know that let us use x equal to a sin theta. So see what we have done. Taking a square common, so this will cut out. Sin theta by cos theta is tan theta, which is theta. Now please watch here. From here, sin theta is what? X by a. So theta will be sin inverse of x by a. So this is your answer. Next, in this sum, let x equal to a cos 2 theta. So this we have written, taking a common, which cuts out. So 1 minus cos 2 theta by 1 plus cos 2 theta. 1 minus cos 2 theta formula is already given. 1 plus cos 2 theta formula given. Again 2 and 2 will cut. So it is tan square theta, which is tan theta, which is theta. Now from here, please note it was written as x equal to a cos 2 theta. Okay, so therefore cos 2 theta is x by a. So therefore 2 theta is equal to cos inverse x by a. So therefore theta will be half cos inverse x by a, and that is what the answer is. Clear? Next, let us see sin inverse x by root over x square plus a square. So let's take x equal to a tan theta. So a tan theta by this, taking a square common. 1 plus tan square theta is sec square theta, which will come out of the root as sec theta. A square will come out as a. This and this cuts. So tan theta by sec theta. Tan theta is sin theta by cos theta, and sec theta is 1 by cos theta, which is cos theta, which is cuts. So it is sin theta, which is theta. So theta is tan inverse from here. Theta is tan inverse of x by a. Similarly, if the sum is cos inverse x by this, let's x equal to a cot theta. So putting these values, 1 plus cot square theta is cosec square theta, which will come out of the root. Cot theta is cos theta by sin theta, and cosec theta is 1 by sin theta, which is sin theta cuts. So this, and so theta will be cot inverse x by a. Okay, friends. So this is the first part of the applications of the inverse trigonometric functions, and we will be discussing more and more of this part by part so that you get the full concept of the inverse functions. Please keep note of all these formulas, whatever I have highlighted. These are very, very important formulas, very important to you, so you have to keep a note of these, okay, so that you can perform well. And you please watch how I am doing the things. You have to note the limitations of the angles which are being shown on the screen. Okay, x can take what values, y can take what values. These are very important. It will help you to decide the range of the functions. Clear? So with this we finish the trigonometric functions first part, and I will be soon coming with the second part. Okay, so till then it's goodbye from my side. Thank you so much.